Okay, I've started recording.
I am same here.
You gonna start
Dark.
share screening, Adosh?
Dark.
Yeah, I guess we can start. Let me get my screen recorder as well.
But we don't need 3 screen recorders, but sure. I think she and me are more than enough, but okay.
Bro, where are these kids like Joelle and Jay?
I think Joelle said she had a camp or something like this week, so she couldn't make it to
Yeah,
the morning
I bet
classes.
everyone has camps over the summer break.
Oh, yeah, Jay.
I have so many.
She said she had tennis yesterday, so I thought it was just a class, but it might have been a camp.
Oh yeah, it's a tennis camp, I think.
Oh, I took those a while back. Oh. Those go to like all the way to like 12, so I think it's all the way to lunchtime.
Okay, so someone else joined. Okay. Now I will start recording. Okay, so hello everyone. Welcome back to the second day of our summer camp. Today we'll be finishing the experimental design. Like, we'll be finishing the experiment we started yesterday, and we'll also be picking who does what part and what thing they'll be studying for the next, like, for the rest of the year, basically. So let me share my screen with you guys. Present. Okay, can you guys see this one? Can you guys see this?
Yeah.
Okay, so now we finished the first half of it, up until sample calculations for the quantitative data, I believe. Now we'll go on to graphs. Okay, so for graphs, basically you're either gonna use a line graph or bar graph to represent the averages of your data, and you should always usually only do averages, since that's what you're gonna have time for, and that's what they really care about anyway. So what you're gonna do is you're gonna use the Sultan graphing method, which was like scale, units, labels. What was T? I'm confused. Wait, what was T? This was you, Howard. This was you.
Wait, what? How is this me?
The Sultan graphing method. You did graphs, right? You're gonna have like a proper scale on each axis.
Title.
Yeah, titles. Okay. Titles. Yeah. Okay. You have to have the proper scale on both axes. You have to use proper units. So use the same units on this axis and the same units on this axis. See, all units centimeters. Labels. Make sure to I would label the top of these and label the axes. Label each level. Just do that. And then for titles, you should always have a title like this. Usually the easiest thing you should do is the independent variable versus the dependent variable. And then A is just accurate. Just don't make a weird graph. Just make it accurate. And then N is neat. So make the graph neat so that the proctors can understand what is happening in your graph. And another thing, if it's a line graph, you should try to, if it's like a line graph, yeah, you should try to show the line of best fit.
But the key part about the line graph is that it's only measuring something over time. That's the only time you actually use a line graph, and that's like its only purpose.
Yeah. Line graph is when you measure something over time. Okay, next we'll go on to statistics. So for statistics, what you want to do is mean, median, mode, range, minimum, maximum. We never did standard deviation, but if you have time, I highly recommend that you do standard deviation because it makes proctors happy. So mean is obvious, just average. Median, just take the middle number. Mode, you're usually not going to have a mode, so you just write NA. On the rare case that you have a mode, you can brag about that later, but I'll explain that. And range, that's obvious, just maximum minus the minimum, and then you have the minimum maximum. And then you have standard deviation, which is basically like a measure of how far each thing is from the mean. We'll go over how to calculate standard deviation later. Or actually, let's just do it right now. Why not? You just plug the formula. I don't want to.
Bruh.
Basically, like, okay, it's too complicated. Okay, well, this is too complicated for children to understand.
It's actually not that hard, but okay.
Yeah, okay. I mean, symbols, but okay. Basically, what you're gonna do is you're gonna take the item from basically the standard deviation of a thing is basically you're gonna take one of the things that is not, you're gonna take one of the data points, subtract the mean from it, and divide it by how many items are in like the data set. And then you're gonna basically find like the geometric mean of it. If that makes sense.
I think you should just get a better formula. It's like way too this formula won't help them.
Here. Just wanna watch a YouTube video about it?
Nah, it's not con, so it's not gonna help us. Just say simple formula. Like Google's really smart.
Sure. Okay, whatever. We'll just do this one. So, okay, how? You know. We search up calculator because those usually have the steps. Standard deviation is a weird thing to explain.
Yeah.
Okay, so basically, you're gonna find out the average of the data set. So, for example, if this is our data, what you're gonna do is you're gonna find the average of the data. So there's 5 numbers, they add up to 13, and the average is 2.6. So then what you're gonna do is you're gonna take every number and subtract the average from it. So 5 become -5 become -7.6, 1 becomes -1.6. You get the idea. And then you're gonna square each difference. And to calculate the variance, now you're gonna add up the square difference and take the square root to find the geometric mean. Do you understand what that means?
Yeah, that made sense.
Yeah, okay. If anyone has any questions about standard deviation, you can like either email me, Howard, or Sheep later. It's just like one of the weirder statistics. We never did it, but like if you have time, I definitely recommend you do it because it helps at other parts. Okay, and then you have to show sample calculations for each of your things. So I actually forgot to do it for standard deviation, but you would do that for standard deviation as well. But what you basically do is you just show how you calculated one of the things. So for example, to show how we calculated the mean, we just take this example and just show, okay, for this specific mean, we did this, and then we got this. So this is basically how you would do standard calculation. Standard.
This is the easiest way though. This is actually the easiest way though.
Yeah, sample calculation.
Yeah.
And then for standard deviation, you would do the same thing, but I got lazy. Okay, and then analysis, Sheep, you explain this.
Okay, so the analysis is basically where you're going to talk about all of your data points and flesh out your reasonings for all of your thoughts. And
I think this is the most important part of the entire lab right now. It's the most points, and you have to do it the best.
Yeah. I'm sorry, my voice is kind of dead, but like so the first step is you have a claim that is explained thoroughly. So one of the easiest ways to make sure that you have a claim is to like do boxes with claim and then evidence and reasoning, as you see on the screen right now. So the claim is really going to be like what you're trying to explain about the thing that you're analyzing.
A certain topic. So when in analysis of claim at CER, basically, you're gonna have to analyze the statistics, the outliers, and the data trend. So your claim has to be pertaining to the certain topic that you're analyzing in that specific CDR. So in the CDR, we're analyzing statistics. So this claim pertains to the statistics. Okay, she
Yeah,
continued.
So continuing on, so your claim should be like, well, Adarsh always bugged me about making it more fancy. You don't have to, I guess, but like it's recommended, so I guess you should. And then there's the evidence part where you basically just smack all of your data that you're trying that help you prove your point onto it. And this just you can do as like the first IV level did this, the second IV level did this, and the third IV level did this. This is not where you say the first IV level did this, so this happens. That so part goes into the reasoning category.
This is the
So,
response.
and the reasoning is where you like basically flesh out all of your data points so that instead of qualitative data, they quantitative data they become like sort of they
You're
become
providing,
thought. You're
yeah, you're
providing
providing,
you're providing sorry Adarsh, you're providing evidence for an idea.
yeah, so
So
you're explaining your evidence in the reasoning. So you're gonna explain how your evidence supports your claim and what this means. Okay, she continued.
And then here you what I usually do is explain like so in my claim I oh shoot. So in my claim I noticed that I said the word standard deviation. So when I go to the reasoning, I'm going to want to explain what standard deviation is in my words so that I can use that definition in the rest of the like basically paragraph. And then you can and because this is like consistent like that, you can it's easier to express your point. So that's a tip. Another tip is to talk about something generally, like how should I say this? So talk about like standard deviation as a whole and a perfect experiment or like an ideal experiment, and then compare that to your experiment. So like this is the data, right? Statistics. So I noted that our standard deviation showed the inconsistencies. So I'm gonna want to go back to our ideal like ideal experiment and talk about what the standard deviation might look like in that, and then compare and then notice that in our experiment our standard deviations are nothing like the ones that would be in an ideal experiment. So if so, that can represent either our data isn't consistent or something else happened that like messed up our data.
Yeah. Okay, so then explain the outliers one.
Yeah, so the outliers, Adarsh, if you could go back to the data real quick. Yeah. So the quantitative data. So you guys see how in like level 1 it's 15, 14 and 16, like trial 1, 2 and 3 leading to an average of 15. And in trial 2 it's 46, 30, 40, 36 and 43, which yields a result of an average of 39.6 repeating. But then you go to the third like a third IV level, 75 centimeters, and trial 1 is 65, but trial 2 is 33. That's very high. It's a pretty big difference. So you can safely say that that is an outlier that you're going to want to talk about in this section.
You can take this 33 as an outlier since it's so far from the 66 and 65.
So would it make sense to do something like the trial to number 2? What was that? Whatever that was, 36. So then going back to this, you can talk about, I know, so in your mind, you know that there is an outlier. So now what you're going to want to do is talk about something that represents the outlier in some sort of data thing that you did in the sample populations and all that, and the statistics. So you don't want to talk about the individual like point. You can, but you should like have it as a there should be something more to it, like oh, this is a data point, when in comparison with the other ones, does this. So we can think like, oh, we did something wrong, or you'd have to like do a lot of more stuff. So it's better to attribute your outlier to something else, like a range or like a mode.
Yeah.
Those are the main things. If it's you, I mostly do range because that's the easiest to do, and like the mode, it gets complicated really easily. But there are some instances in which I do mode, but that's beside the point. So going to the comparison, like between your range and the other ranges, you should have that so that you can note how low the values of the other ranges are in comparison to the third range. And then you can use that to say, oh wow, this is a very big range. So we know that there is an outlier somewhere in this data. And then if we look at the data, we can say that the high range, and like what I said, that the high range of the third IV level means that in the IV level an outlier exists. And again, and then here we're going to look at the instead of looking at the ideal experiment, I look at the pattern, like that should have been. What should have been, what could have been, what would have been, if that like second trial outlier didn't happen. So then I say like, oh, the specific value is 33, much lower than the 60s that we predicted. So that's really it for the outliers. It's not that hard. And
Yeah,
darn is the one thing that I'm good at.
and one thing that you want to keep note in the outliers is if you don't have any outliers, you can just say like, since our experiment was consistent, that's why we don't have any outliers. So if you don't have any outliers, that's something else you need to do. And then data trend analysis.
And then the data trend, okay, I'll be honest, I kind of got a bit lazy here. But so the claim, throughout the experiment, we were able to observe a positive trend overall. So the data trend really do the like points go up, down, or just randomly, or if it's like or like the same. So on your graph, can you go back to the graph? Sorry. So on the graph, you can see that the bars, like overall, they grow like 15, 39, 54. They're going up, like, so you can attribute that to some sort of thing, and then just smash that into the data trend, and yeah. So the real thing that you're going to use is the means, because those are what's on your graph, and the graph acts as a visual representation to prove your point in the data trend. So you want to like do something with that, or with either the data points or the graph itself, or the mean, or something like that. So the first IV level, the second IV level, the third IV level, if it goes up, you go positive. If it goes down, like the first IV level is the biggest and the final IV level is the smallest, it's down. You go down, then you can say that like, oh, we know that the first IV level is bigger than the second IV level, which is bigger than the third IV level. So we know that overall it's trending downwards or yielding a negative correlation.
Okay, just something to add on. If you look at there's just different types of data trends. So you can have like linear trends, exponential trends, dip trends, seasonalities. There are many different types of trends, but the ones that you're most likely gonna have at your competition are irregular slash random patterns, and this usually means there were inconsistencies in your experiment. You might also have exponential trends. However, these are more rare, and what you're usually gonna have is just a linear trend. Okay.
Hold on,
Okay, do you have anything else to add, or is that it?
yeah, I do.
Okay.
So going back, so the positive data trend, the negative data trend, if it's equal, then you can say that. But I don't think you're gonna have an experiment where it's equal. So that's like, and then you can tie the outliers. So I'm sorry, I'm kind of jumbled up today, but so the outliers you can attribute, or you can connect to the possible experimental errors, which is again like part two's part. So it's really important. Another thing to note is that it's really important to have like to be able to adapt to a certain situation. Because you see, like these claims and these CERs, they really like rely on having knowledge of some other part. So if you want to be good at part three, you need to know at least something of part two, or like something of part one. Yeah, that's it.
Okay, Howard, do you wanna do experimental errors?
Sure. So experimental errors is basically like a cause. You're supposed to go like step by step in how just one error affects the data as a result. So if you read what I wrote, it says when lining up the ball of the line marking 25 centimeter, 55 centimeter, 50 centimeter, and 75 centimeter. If you look at this, you'll see that I'm trying to be as descriptive as possible because these proctors, they just, you need to be very descriptive because these proctors don't have like a visual image. They're not gonna like look at the experiment and try to find what you're talking about. You have to like describe every aspect of the experiment yourself. And it's this, I guess this part's really good for people who like can actually like visualize it in the head, which is like exactly what I do. So the ball's bottom is lined up using a human's eye. This means that the ball could have been slightly off as the human eye cannot see down to the nanometer and thus cause the drop height to change. With the drop height change, the rebound height would change and cause our data to be invalid. And you can see here that it's a step by, you're supposed to go through a step by step to show how one thing can always affect the data, and that's how it's supposed to go. You're supposed to always say that it will cause our data to be invalid at the end because that's how it's an experimental error. So usually it's human error. It's usually human error, maybe an environmental error, or like how the experiment is conducted because there could be inaccuracies in that method. So for my second possible experimental error, I blamed it on the environment. And in this case, if you read it, if I skip to the part that says these vibrations could affect the rebound height, as it could effectively change the surface the ball is bouncing on, and the ball's rebound height would change as a result of the surface changing every time. And you're supposed to like go into detail. Like I go into more detail than like most people would, and it pretty much, that's how you get full points because it's experimental errors is worth a lot. So like the key part to like doing really good, as I've said again and again, is to do step by step. And then that's basically if you read the vibrations, how they cause the data to be inconsistent because the floor has changes into its surface and therefore it has a change in rebound height. And then the second one, I just said the ball could have had slight inconsistencies because like grooves or bumps, as with most manufactured balls. And then that causes, because the different linings of where it touched the surface means that the difference in height or difference in how the energy is spread. But I chose like how the ball bounces off because it truly changes because the contact is different. Like it's going into detail more than a normal person would, but that's mainly for the reason because if you don't, then the proctors will just have like, well, you need to just connect the points very well, and the proctors will like give you full marks basically.
Yeah, you have to kind of explain what your errors were, and then go into detail about that, and also explain how it affected your data.
Yeah. They say 2 errors. I would recommend 3. You probably won't have time for 4. 3, because experimental errors, the person doing part 2 is usually the person doing the experiment. So in most times you're actually low on time. So you're probably gonna be rushing on this part. But you have to be like the person who writes fast and already has a visual in the head. So it's like very easy to write it all out onto paper. And
50
you always
minutes
have to,
seems like a lot, but it really isn't.
yeah. And the key part is just know that data would not accurately reflect on the ball's rebound height. You need to always say that the data would not be accurate or be invalid. That's always a key to saying that the experimental errors is invalid. And that's pretty much it.
Yeah. Okay, so now I'll go over conclusion. So in the conclusion, it's basically another CER, except you're answering your hypothesis. So basically, the only thing that's different from a traditional CER is in the beginning, you're gonna restate your hypothesis, but without all of like, if you go back, you can see that in this actual hypothesis, we have all this scientific information and we included all the independent variables. When you restate your hypothesis, you don't need to do any of that. you can just say that we predicted that as the drop height of the ball increased, the rebound height of the ball would also increase in relation. So you're just gonna restate what trend your hypothesis predicted. So after that, it just goes to a traditional CER. Except your claim is going to be whether you reject or accept your hypothesis based on your experiment. So in this case, our claim would be we can clearly accept our hypothesis. And you usually want to say like stuff like clearly in order to show that you're taking a strong stance. So the usual stances that you can have are it our experiment rejects our hypothesis, our experiment accepts our hypothesis, or our experiment had too many like errors to actually tell. But if your experiment had too many errors to actually tell, you're probably not going to get a good score anyway. So the next thing you should do is provide your data, which is basically your averages from each level. So the average from level 1 was 25 centimeters, yada yada yada, stuff like that. And then next you go on to the reason. So you're basically going to explain that in this case, our data shows an upward trend, and this supports our hypothesis, which also predicted an upward trend. And then you go on to like, this clearly supports Newton's third law, because you want to include scientific aspects, like scientific theories and stuff like that, and laws, in order to show that they clearly support your experiment clearly supports them, and this shows that it kind of follows the laws of science. And then at the end, you usually want to end with our experiment shows a clear X type of correlation between the independent variable and dependent variable. Now we'll explain recommendations for future experimentation. Okay, so applications and recommendations, basically what you're gonna do is you're gonna explain what you could have changed in your experiment to make it more accurate, what you could have what other independent variables you could have tested, and how this experiment could be used in the real world. So what we did was we said that in the future, other experiments that we could test was instead of changing the drop height, we could test the material of the ball in order to like test elasticity and see how much energy a material could retain or lose. So you basically want to come up with a different experiment that you can also test. And then the next thing you want to do is explain a better way to like collect your data almost of how to improve your experiment so it would be more accurate. So in this case, what we could have done is instead of catching it at the top height, we could have used a timepiece and measured how long it took for the ball to stop bouncing. Since that's much longer, it's much easier to see when a ball stops bouncing rather than when it's at its highest point. And then the next thing we include is how this could be used in the real world. So for the ball drop, it's just pretty simple. It's like in the real world for people designing balls for sports or researching energy, things like that. So I think that's all we need to go over for the entire like experimental design lab write-up. Howard or Sheik, do you guys have anything to add?
It seems good.
Yeah, okay. So now I guess we can choose who does each part. Or do any of you guys have any questions first?
Don't be afraid to ask, by the way. Like, I was helping someone, and I think they got it now. No questions?
I have a question. So can you guys go over what part does what, like part of the ED?
Okay, so basically part 1 does basically most of the writing. Part 1 does statement of problem, hypothesis, variables, conclusion, and application recommendations for further use. So part 1 is not going to do any of the experiment, they're mostly just the people writing. Part 2 and 3 both do the experiment, but part 2 does materials, procedures, experimental errors, graphs, and statistics. Part 3 does qualitative data, quantitative data, and analysis of CER. Part 3 has the least amount of things to do, but analysis of CER is the most important thing and is one of the longest things. So that's basically it. So if everyone can type in the chat what thing they prefer to do, because then we can kind of decide. I'm trying to keep it at 5 people per part so we can have a good number of teams.
Wow, everyone's part 2. Everyone's choosing part 2, I guess.
Howard, your part is popular.
Well, that's because it's.
It's
Never
one of
mind.
it's probably the most fun, but whatever.
Yeah. Oh.
Mm-hmm.
Okay, there's too many people doing part 2. Some of you have to like do part 1. Okay, wait, let me create a Google Sheets and then you put your name and then you put your part.
I have one person doing part 3.
Oh. I
So
thought there were 2, but then I realized like the Sheik typed on the chat himself.
Shit, stop, man. Shit.
hey.
Okay, people, put your name on column A and then put your
How does
part
that
in
work if they don't even have
column B.
access to it?
I'm gonna share it to you guys.
ED part.
People parts. Why can I never spell people right?
It's because you're typing too fast.
Well.
Wait, why didn't I copy the whole thing there? Okay, I'm putting this link in the chat, and then everyone put your name in column A and then your part.
How about just do like columns, like part 1,
Each part is important. Just remember that.
2, part 3.
Oh yeah, I just realized a Sheik does have the smallest part though.
Yeah.
What do you mean?
But see, you are. See,
Yeah,
I
I
have
know,
to
I know,
do
I know. I
60
understand,
people.
I understand. I understand.
You have like one CER. I have to do 3 in like 20 minutes. Excuse me?
Ashik, you took 3 weeks. Sit down. Be humble.
Darn it.
It took me 5
I've been
minutes to
really
write the
cool.
possible experimental errors. We're supposed to do all this in like less than an hour, Ashik. So we should be able to type even faster.
Yeah, well, we do it in less than an hour, but like stuff happens.
Yes, stuff happens, Ashik. It takes 3 weeks.
I'm
Oh, or
sorry.
you can do that, I guess.
This would be easier. Okay, so far 6 people have. Oh.
I like how part 2 fills up immediately though. Oh wow.
Remember how last year, like, there was a even split of people? Like,
Not even split actually, but sure.
yeah, because I was the only part that had, like, who did we have? Me and Oliver. That's it.
Oh yeah.
And then
Oh yeah, James did ED. That's like a long past memory, but James did ED at one point.
James?
Yeah, James was in Navy.
Yeah,
Oh
James
my
did
god.
ED. You forget all these things
I
until you're like,
swear.
oh wait, James the physics guy.
Hey, hold up. My recording is just so bad. So is it okay if we just use Howard's?
I'm recording as well.
The problem with my recording is that I hear all these like boom booms. I don't know. It's usually probably just because Adash did it again, but it's probably just because like a background noise in the end.
Yeah, probably.
So we should like try muting when the other person is talking. I guess that would probably fix a lot of the stuff.
Yeah, but I can't really mute because I'm sharing my screen, so I have to keep on switching back and forth. Okay, did everyone here put down their name? There was like how many people here?
9.
9?
It should be 333.
Yeah, it should be 333. 2 more people have to do it. Once those 2 people finish, we can end class for now, I guess. A sheep. No.
Where's our other two people?
I don't know. I mean, we're done with class for today, so that's all that people have to do, and then we can finish.
Oh yeah, I have to teach another class after this. Oof. James leaves the circuit lab to me without a lesson plan, and he's like, "Oh, you can probably do it, Howard." Oh my god.
Imagine having a lesson plan or like slides or something.
Oh yeah, my original plan was to not make slides, just use a whiteboard and try to see what I have to do.
You're lazy children.
Why do you guys say I'm a machine? I'm literally just a student in machines. I'm not even a teacher in machines.
I know, but you're Howard. You deserve like 10,000 points.
Oh my god. I can't even see that, but like sure.
Yeah,
Wait,
that's
are you just listening to machines recordings?
yeah. I think you are. I think that was your plan. But then the machines
Yeah.
recording the thing is like
Yeah, the recordings they can't record it properly.
I need to study machines because I might try out for it in high school.
Machines is in high school. Oh yeah, it is in high school. Division C machines. But Division C machines is not only simple machines, it's very heavily focused on
Compound,
transferring
yeah.
kinetic and potential energy. And
mhm.
also focus on acceleration velocity. It's a lot more like physics 1 and physics 2.
Hold on 1 second.
Okay, wait.
Why is
Someone from part 2, I would recommend you switch to part 1 or 3 because too many people. Wait, let's just get this for now.
Just use a random number generator.
J is doing this. And then there should be more people here. How about we just put this as like homework?
Howard? You have a minus 0.01% in our class.
I know. I saw the updated your grade. I got a notification just now from my iPad. I link all my notifications to my iPad so I can hear anything. Facebook Messenger, Google Classroom, everything. Oh my god.
I'm like,
Okay.
I'm trying to update it so that you have like
Wow, I see a 99.999999900 something like that. I think you can hear these notifications, but like, okay, sure.
yeah, we're great.
I have 2 private comments. But I didn't even look at the machines, and now I'm like, oh.
Bam.
Heck, lesson 10 final test. Okay, you know what? Oh, I can report abuse. Okay, so second of all,
No,
I'm not
please.
joking with you. I'm not joking with you. There's that random function, and I'm pretty sure it's just like that YouTube thing where if you do that, it's probably something bad happen. But I'm not gonna do that. Oh wait, so we need
No, I'm
like
just giving you. I'm giving you more than you're at 75,75538.03% right now. You need to get to at least 100,000.
oh my god, Dash, is this all the people we need?
For what?
Uh, ED. Because the key thing is that we're supposed to form teams at this rate. Or like focus working groups.
I mean, our next class is gonna be like most likely just walk through a test together, and then we're gonna have like an actual test.
I'm pretty sure that's like way too rushed for sure.
Howard, I've broken your grade.
No, are you able to hear the dings from notifications?
I think you guys can hear the things.
Yeah, because I always have a notification.
Come on. No! There. Come on.
Have you figured out all the groups though?
No. How would
I
I
guess we
start?
should give a more overview of what happens during the experiment. Then we've only told them like what
The
to
part.
do, what to write, but like how does like all the stuff work? I think that's the key, cause like not everything just comes down to how we do it. I mean, that just comes down to following the diagrams or what we just showed them the example.
I mean, you can get like a decent score by just following the diagrams. Let's be realistic here.
Well, let's be realistic. I'm pretty sure it's time. It's very time consuming. In fact, all our competitions are always finishing last minute. Every
Yeah,
time we
We
that's
finish
true.
finished
early,
overtime. What do you
yeah.
mean?
Oh yeah. We always screw up our first experiment, and then we go to our second experiment, and then we barely have enough time to finish that. That's always our competition strategy. That always like does not work too well.
Oh yeah, another thing by the way, just another thing to note is that what you want to do is decide on an experiment 5 minutes in, and then just commit
Yeah, like you have
rather
to
than
decide the
spending like the
experiment
whole
very
of part
fast.
one on making an experiment.
Yeah, like yeah, basically. You don't want to waste time. We last year spent too much time, so we rushed on these parts. It's not like we didn't finish them, but it was like almost there. Oh, and also it's not a recommended rule, but you know how you can see people around you doing the experiment? You might as well just take an idea from them. I mean,
That's
Howard
cheating.
encouraging cheating?
it's not cheating because
Wow.
Oh, is that how you came up with all of our experiments in class?
I mean, look, you have people doing the same thing using the same materials. I mean, the hardest ones always come down to chemicals, though. Chemicals are the hardest one to experiment with.
Yeah.
Yeah, it's so dangerous.
You guys should also research like basic science ideas or like science stuff, I guess, because like you should know basic physics, like not like simple machines level physics, but you should know like Newton's laws, how to calculate gravitational kinetic energy, just basic stuff like that. Basically everything they teach in 8th grade physics, you should know that. You should also know about like basic chemistry, I guess.
Yeah, that's basically it.
Yeah, that's basically it.
Yeah, that's basically.
And random science topics. Like last year we had something about like diffusion or something.
Oh my. No, but they gave us the definition of diffusion.
Yeah, but like half like I think JCM didn't understand what that definition meant.
Oh yeah, the fusion. Literally, it was the dumbest experiment I've ever seen. We literally just tested how long it would take for something to sink or something.
Yeah, it
In
was pretty
different
dumb.
liquids. It was like the dumbest thing, yet they proctors accepted it, which is like pretty amazing by any means.
Did we play
Did
this?
you like medal that time?
Oh yeah, didn't we make up like some data that time or something? Oh,
Wait, that was JT. We medaled.
yeah. But I think didn't we I don't know didn't we make up data? We usually do that for a lot of our competitions though.
The only time we got first though was Ladera and Carmel, and Ladera was team 2.
Yeah. We got first at Carmel.
Yeah. I don't think you were there. It was me, Jay, and Yashika, I think.
No, I was there, but I wasn't doing ED at that time.
Oh, I see.
I was doing circuit and density, mostly focused on that.
We almost got DQ'd in that comp too. We went from almost DQ'd to first.
That's the
Yeah.
worst. Literally, I think the only reason we didn't get DQ'd is that our like Sierra Vista was proctoring ED.
Rig. But
But
like,
hey,
yeah, but like actually, the hardest part is probably time management because you seem 15 minutes is a lot, but you're probably gonna like if you don't manage it well, you probably might spend way too much just trying to like figure out what the experiment is. Like that's usually the hardest part because in all of these like invitationals, besides regionals, they always try to give you a chemical experiment or like an experiment that invokes creativity. So like you actually have to like think of an experiment. It actually takes time, more time than you actually realize need to put in.
Remember, find the density of an egg.
Oh, that one.
which one was that actually? That was like
That
trash.
was, I
That
think
was
that
trash.
was,
Oh, yeah, we used some big brain simple machines to figure that one out.
that was like Mason or something. I don't know. It was me, Ashik, and Sean, and then we each failed.
Yeah, but we used some big brain like strat to figure something out. Like we used simple machines and we used density lab, even though like none of us were in density lab.
Yeah, it helps if you're in like different events, like simple. If you're in like simple machines, it'll probably help you for ED. If you're in crime, it'll probably help you for ED.
Simple, crime, and density. Those are the three that I can see. And density really only because of that like density of an egg prompt.
Yeah, but then, like all of these these practice sometimes they're like, oh, we'll give you an easy experiment, what competition. Then the next they're like, let's give you a BS chemical experiment, give you a definition that you've never heard of, while the experiment itself isn't truly that hard. That's JT for you. JT was actually hard. They like got Division C stuff and just told you to do it.
Wait, what was JT's experiment again? We meddled that, I remember.
It was diffusion, and then they gave us
Oh yeah,
different
diffusion.
liquids. They gave us different liquids, I believe, and then the hardest part about that was figuring out what diffusion had to do with those liquids, and then it turned out to be extremely simple though. It's literally just testing how long it takes for something to go through something. Yeah. But that's the hardest part though, finding the experiment, I believe.
It is.
Well, do you want me to pause this? Pause the recording or?
Yeah, I think you should pause the recording.
Okay.
Yeah, I'm gonna stop my recording as well.
For everyone else that's still here,
Yo, wait, if you have any questions, ask them right now, because we're gonna stop the recording.
I want to stop the recording after these questions are asked then.
yeah.
Yeah. That's why I was asking right now.
No one has any questions?
Well, good luck on the practice ED test. We'll send out.
Today?
We'll send out one sometime.
Yeah, we'll send it out. Okay, yeah. You guys can leave.